a little recap or intro lesson to interval notation, set notation, number lines, and how they're related to each other. Interval notation is used to indicate all of the numbers between two endpoints. So the interval 3 to 9, how it's read, for x element of real numbers, this means all the real numbers between 3 and 9. This means all the natural numbers between 3 and 12. This means all of the real numbers between negative infinity and 1. And this means all the integers between negative 4 and infinity. Now the way these work is that, and we'll talk about this more in a minute, the way the brackets are facing, whether it's towards the number, like both of these, or away from the number, the way this one is, tells you whether the number itself, that endpoint, is included in the interval. So 3 to 9 includes both 3 and 9. It includes 3, it includes 9, and it includes every real number between 3 and 9. So it includes 4, 5, 6, 7, 8. It also includes 3.1, square root of any number that falls in between 3 and 9. This one here includes all the numbers between 3 and 12 that are natural numbers, but it does not include 3. This one does not include 1 or negative infinity. Actually, infinities are never included. This one does include negative 4. So another way to represent that same information is on a number line. And this is what this would look like on a number line. So we talked a little bit about which things are included. This 3 is included. And the way we show that on the number line is with a filled dot. The 9 is also included. The bracket is facing towards the 9. That also gets a filled in dot. And because this particular interval had real numbers, that refers to all real numbers. That refers to every possible number between 3 and 9. And the way we denote that is by filling in a solid line on the number line between the endpoints. So this is the number line, which is equivalent to this interval. The second example that we had looked at, this one here, goes from 3 to 12. So on my number line, I spaced them out from 3 to 12. The 3 in this case is, actually this is the opposite. This should say the opposite. The dot is right. The 3 is excluded. And the 12 is actually included. I'll fix that up. Excluded. Included. Okay. So the 3 being excluded gets an empty dot, not filled in. The 12 being included gets a filled in dot. And because now we're talking about natural numbers are only positive whole numbers. So it can be 4, 5, 6, 7, 8, 9, 10, 11. It can't be 3.5 or 3.1 or 3.01. And the way we show that is by only including whole numbers, only putting filled dots over the whole number, just the natural number parts of the number line. Any interval that has an infinity in it, negative infinity or positive infinity, an interval is always listed, the two numbers in the interval that is, are always listed the smallest one first and the largest one second. And on a number line, that's the same as the smallest one is equivalent to being the leftmost, and the right side here, the second number, the larger number, is the one that is furthest to the right on the number line. So the interval negative infinity to 1 means that 1 is larger of the two, and it goes down leftwards on the number line all the way down to negative infinity. Because the 1 is excluded, it gets an open dot. Because it's real numbers, it gets filled in, and because it goes all the way to negative infinity, we indicate that with an arrow. So it has an arrow at the end, and a solid line starting from the 1, going to the left because it was negative infinity. This shows that this interval includes all real numbers smaller than 1. So this would be 0, -1, -2, and it includes all of the decimal, rational, and irrational numbers in between. This was not the fourth one that I showed on the first slide, but if I had shown you an interval like this, 1 to infinity, where the 1 is included, infinity is never included, and talking about real numbers, here 1 would be the smaller of the two. 1 is the leftmost, it's the first number in the interval, so we're talking about numbers that are larger than, or could be equal to, 1 is included, larger than or equal to 1. And on the number line, I would start from 1, because now we're looking for numbers larger than, I would move to the right. Again, because the 1 here is included, it gets a filled in dot. Because it's real numbers, it's going to be a solid line, and because it's going to positive infinity, it goes to the right. And the last way to show this information is something called set notation. So this same interval that we looked at on the number line and as an interval, it means the same as this. This is what the notation is. So I'll take you through each different part of this. This first part, x and line, just means for all x's, such that it's just a part of every single set. That's how it starts. It's a notational thing. What we're saying is that this group of numbers, all the numbers from 3 to 9, is the same as a set, which is made up of all x values, such that x is between 3 and 9. X values that are bigger than 3, and x values which are also smaller than 9. And then this last part here just lists the same number set that was listed in the interval. So if you have an interval that has two numbers, in this case 3, 9, those will be the two numbers on either side of the x. And you have to decide which one's included, which one is excluded. In this case, because both the 3 and the 9 were included, they both got this symbol here that has a line underneath that were equal to. In a case like this, when we're talking about natural numbers, going from 3 to 12, where 3, because the way the bracket is facing, is excluded, and 12 is included, we would have, again, x such that. Here we would go from 3 to 12. So again, my two endpoints of the interval go on opposite side of the x. The 3 in this case is not included. The 12 is included. And I just copy the number set. Now, if there's no second number, infinity is not a real number. In this case, there's just a 1 and then this infinity. The way you write the inequality is a little bit different. I'd still write x such that. I still write it in set brackets. I still copy down the number set. But to show from negative infinity to 1, all I have to write is that x is less than 1. And that implies that it keeps going on and on, everything less than 1 forever. So that would just have one endpoint. So normally, if your interval has two number endpoints, you would have an inequality that has two pieces. And if there's just one, if the other one is an infinity, then you would just have one number with an inequality symbol. And the same for this idea. Something like this would be all x's greater than or equal to -4. This should have been the same. You would just copy down the number set. And that is how that works.